her the respect authority of archaeology of the South Caucasus. Hereby, before I will give the stage to Professor Elena Rova, I would like to give you small house rules. Please, if you're not going to speak, mute your audio and also switch off your camera. If you have any questions, please write in the chat box or click on the right-hand button and you can ask your own questions. Now the stage is yours. Elena, please. Thank you.
Thank you. So you have to switch off the screen to, yeah.
Sure.
Ah, okay. Now it's fine. Okay. So good afternoon to everybody. I would like, first of all, on behalf of all the participants, to warmly thank Magda Batiashvili for organizing this very interesting workshop. So archaeometry is a field which has incredibly expanded in the last decades and attracts more and more young researchers, but still has enormous potential. It is virtually impossible to provide a complete review of recent research. Thus, our speakers will just tackle some of the possible topics, approaches and methods, focusing on different materials, ceramic, metals, glass and obsidian. I'm especially happy to see a high presence of researchers from Near Eastern and South Caucasian countries, and to see that besides veterans of the subject, such as Ruben Badalyan, young scholars are also very well represented. So as for myself, I can hardly be considered either an early career researcher or a specialist in archaeometry. As an archaeologist working in the area, however, I have also tried to integrate archaeometric research about pottery, obsidian, artificial materials, and so on, besides other methods of archaeological science in my field research, by establishing collaborations with different specialists. So I have been asked here to present a short synthesis about the archaeometric analysis we undertook on early Bronze Age pottery from Kashuri in Zagora and other sites of the Shida Kartli region in Georgia, in the framework of the Jordan-Italian Shida Kartli archaeological project of Foscari, in collaboration with the Georgian National Museum. Co-directors were Marina Puturidze, Zurab Maharadze, and myself. The work was mainly carried out by Martina Babetto, at that time a student at Foscari University of Venice, in collaboration with Professors Lorenzo Lazzarini of the EU of Lab in Venice and Professor Dario Visona of Padova University. The results are published in Journal of Archaeological Science Reports 35, and they are presently being revised for the final publication of the excavation. So the archaeological problem was the following. The site of Nazargora in the Shida Kartli region of Georgia had been excavated in the 1980s by a Georgian expedition, which has brought to the light, among others, very interesting early Bronze Age ceramic material, which had since then remained partially unpublished. The material belonged to two main different pottery styles, Kuraraxes and Bedeni. So in planning the new publication, besides revising the controversial stratigraphical relations, a topic on which I will not dwell on here, we aimed at better characterizing them, not only from the morphotypological point of view, but also from the technological point of view by investigating fabric composition, building technique, surface treatment, and so on. For the Kuraraxes pottery, which has a wide distribution area and for which archaeometric analysis were available from other areas, we were interested in seeing if our results would suggest a common technological background of the Kuraraxes groups, or possibly any evidence for vessel circulation. As no comparable studies existed for the Bedeni production, we mainly aimed at defining its typical features to provide a term on comparison for future studies. So we also wanted to verify the presence at the site of a third pottery style, Marcopi, which is considered to represent the earliest phase of the early Kurgan period, to which only few items from Nazargora could be tentatively attributed. So on top of the slide, there are typical examples of the three styles from different sites, and on bottom, the sherds from Nazargora. Accordingly, so in the first step of the research, we collected about 100 early Bronze Age sherds attributed, according to both their visual appearance and their morphology and decoration, to these three styles from the Nazargora materials and a few similar ones from two neighboring sites, Tsikyagora and Berikeldedi, which should serve as terms of comparison. We also collected 3 local clay samples. The sherds were subjected to macroscopic analysis and observation by a binocular microscope and preliminarily divided into 4 groups. So 34 Kuraraxes ones, 21 Bedeni fine, 35 Bedeni coarse, and 8 possible Marcopi. 50 of these sherds were subsequently thin-sectioned and analyzed under polarizing microscope and SEM EDS. 29 of them were submitted to X-ray diffraction, XRD, and 22 to quantitative chemical analysis by ICP AES and ICP MS. Results of all these analyses are detailed in the 2021 publication. In accordance with the aims of the study and also to my own competencies, I will here concentrate on the archaeological meaning of the results. So first of all the materials identified in the thin sections are consistent with the lithology of the Kartalini Basin and more specifically of the Kashuri region, although none of the specific compositions of the analyzed sherds corresponded to the clays quarried near the site of Nazargora, which were therefore not used for their manufacture. This indicates for all stylistic groups the use of heterogeneous raw materials found at a short distance from the settlements, originating from alluvial deposits accumulated along the middle course of the Kura River. Although in all cases local clays were employed, clear differences concerning clay preparation, tempering materials, manufacturing techniques, and surface treatments could be observed between the Kuraraxes and the early Kurgan groups, suggesting precise, culturally driven choices and precise aspects of innovations in pottery manufacture between the two periods. Kuraraxes pottery is characterized by an heterogeneous fabric paste. Clay was used as found, that is without any seasoning, shown by the presence of ARF, argillaceous rock fragments, on most thin sections. They are small-sized inclusions constituted by lumps of clay minerals and iron colloids not assimilated in the fabric paste. In some cases, no tempers appear to have been added to the clay, whereas in some others, fragments of granitic and lava rocks were added to the paste. Bioclasts are extremely rare and were probably not intentionally added to the paste. Krog, or crushed pottery, or chamot, constitutes one of the most common tempering agents employed by Kuraraxes manufactured, but is not present on all samples. Even though neither radiographic nor chemooperatoire tests have been conducted, Kuraraxes pottery was almost entirely handmade, most probably with the slab method, and does not show any clear connection between fabric paste and vessel morphology. So they are all the same paste. The majority of Kuraraxes sherds present the typical bichromatic pattern colors obtained with a precise control of firing atmosphere, with black or dark serious surface, except for the rim, which is instead red or dark red, like the inner surface. Surface varnishing is especially characteristic, and besides its aesthetic value, it provides the orientation of mineral particles and smaller inclusions parallel to the surface of the vessel, pushing the sizable ones inside. In addition to this, on a limited number of samples, the traces left by a proper ceramic slip and gob are visible. It's the dark red line on the image on bottom right. The clay utilized for the slip was similar to the one employed for the fabric matrix, although more purified, thus containing higher quantities of iron oxides, hydroxides, so red hematitic ochre. Some analyses have in fact underlined different concentrations of iron oxides, higher on the core and on the surface of the vessel, but limited in its proximity. No specific tests were undertaken in order to determine the precise firing temperature. However, the microscopic aspect of the matrix and the presence and state of conservation of primary calcite observed in the microscopic examination of thin sections and XRD analysis allow us to hypothesize a relatively low firing temperature. In spite of the continuing use of local clays, early Kurgan pottery production can be clearly differentiated through some distinctive elements. First of all, the use of grog as tempering material apparently disappears. Pottery production appears in the overall more careful and characterized by some degree of intentionality in the selection of different raw materials and tempers for different types of vessels. Bedeni pottery in particular can be clearly divided into fine and coarse ware. Bedeni fine ware consists of refined and elaborated vessels, probably for display and use in particular occasions, banquets, funerary ceremonies, and so on. As clearly visible in the thin section, it is characterized by a very compact paste with small-sized mineral inclusions. The presence of purposely finely crushed obsidian, the grains measure about 0.2 millimeters, was observed exclusively on some, though not all, Bedeni fineware sherds. Obsidian, imported from the Chichiani-Paragavani source, was found in large quantities at Nazagora, usually in the shape of flakes. The reduced dimensions of the grains allow a better integration with the clay matrix, thus helping the potters to manufacture the characteristic thin-walled vessels with a thickness range between 3 and 7 millimeters. Since, to the exception of obsidian, the same sources of clay and the same raw materials and tempers were used as in the remaining production, the differences that characterize Bedeni fine pottery are owed to a more careful clay selection and to an accurate choice and treatment, so sifting and crushing of the temper. Moreover, the majority of Bedeni fine ware presents an ISO orientation of voids and inclusions. You can see the same image on the left, suggesting a finishing, if not a manufacture, on the slow wheel. These elements, associated with a careful polishing, create the metallic shine that characterizes Bedeni fine ceramics. A slip was never observed on the surface of our samples. Nonetheless, a high concentration of iron on the surface of the sherds is confirmed by SEM analysis. This proves a strict control of the firing atmosphere by the potters, since if Bedeni fine vessels had been subjected to an oxidizing atmosphere, iron oxides would have become red. The high concentration of hematite and the exceptional sheen of the surface was the result of a careful polishing. The vessels were subjected to this treatment after the manufacture in order to gather on the surface the finer fraction of the clay, which is usually richer in iron. Firing temperature probably reached higher peaks up to 800 degrees than in the case of Kurax's ceramics. But any courseware is rather different. Already at visual inspection, these vessels show much less attention to aesthetics in their manufacture and finishing. A distinctive element is the absence of any slip or polishing on their surface, although some fragments show an disorientation, voids and inclusions, which suggests some sort of rotatory movement in the phase of finishing. Furthermore, the Deni course vessels were fired in an uncontrolled atmosphere, as shown by their generally light surface colors. The fabric is rich in different types of mineral inclusions. In particular, both granite and lava fragments are attested, but it does not show any peculiar fingerprinting figure, so as in the case of obsidian for fine ware. Nonetheless, granules appear rounded and are all roughly of the same dimensions. This suggests that potters probably sifted the river sand before using it as tempering agent, showing more attention and care to the first phase of the vessel's manufacture. This testifies to a clear technological progress compared to the Kurarax's production, which allowed to obtain stronger and more compact vessels. To sum up, the Deni potters manifest an explicit will to diversify between everyday coarse and fine pottery. The differences between the two wares are evident not only in their morphological repertoire, but also in every step of pottery production, from the selection of raw materials to the treatment of surfaces, which are all the object of very precise choices. So the last of our potsherd groups, which we tentatively attributed to the Marcopi style, yielded more ambiguous results. The paste is apparently characterized by a remarkable presence of granites, clasts, or minerals, but it is not clear how this should be interpreted. Besides this, they apparently show intermediate feature between the Kuraraxes and Bedeni production. These sections show a dark black but not uniform matrix, which is an index of firing in a reduced atmosphere. Before firing, vessels were probably slightly varnished. Analysis of Marcopi samples from other sites would be necessary in order to confirm or disprove these results. In fact, the sherds from Nazargora we analyzed do not represent very typical examples of the Marcopi production as attested elsewhere. So to conclude, I would like to briefly mention that our research group continued during the following years to collect ceramic samples from Nazargora and from Radeti Sorgora, another site of the Shida Kartli province occupied from the early Bronze to the Iron Age. Since 2018, when the team moved to the eastern province of Kakheti and launched the Georgian-Italian Lagodeki Archaeological project, we also collected samples of early Chalcolithic pottery from Ziteli-Gorebi 5 and of late Bronze Early Iron Age pottery from Chauri. So the aims of the future analysis should be to complete the chronological sequence for periods which were not documented in Shida Kartli, and to highlight elements of regional versus chronological variability in fabric composition and technological aspects of pottery production. We are actually presently looking for some young researcher interested in archaeometry who would like to undertake this analysis, the analysis of this material at Foscari, possibly by submitting an application for a Marie Curie grant. So if someone is interested, please contact me. And thank you for your attention. Yeah. So, should I introduce the next speaker?
I think yes, if there is no questions.
We are taking questions now.
But I saw that there was a hand of Bianca, if I'm not wrong.
Yeah, please. So, Bianca? No, I don't see any hand.
Maybe she was uploading, yeah.
Yeah. Okay, so I will introduce the next speaker, and then we will have the questions after this lecture. So our next speaker is Patrick Degryse. He's professor at the Department of Earth and Environmental Science of the Katholieke Universiteit Leuven in Belgium, and professor of archaeometry at the Faculty of Archaeology at Leiden University in the Netherlands. His main research efforts focus on the history and use of mineral resources in ancient ceramic, glass, and building material production. He is active in several field projects in the Eastern Mediterranean and in the Caribbean. So Patrick, if you are there, the floor is yours. You can start with your presentation.
Sorry, Patrick, we can't hear you. I can't hear.
No, I can't hear either.
Okay. Maybe the microphone or no. Yeah. Yeah. We still don't hear. But so far I see that you are not muted. Can you try? No, we don't hear still.
Let's try without.
Yes.
That possible?
Yeah,
That's good.
that's perfect. Yeah.
Can you hear me now?
Thank you. Yes.
Yeah.
Yes. Okay, but now I cannot hear you. Interesting. Good. If you can hear me, I'll just give the presentation. But if anybody has any comments or needs to stop me, it'll have to be in the chat because I don't hear anything. I am far from an early career researcher. And as is clear from my IT knowledge, not very well preserved either. But let me present something very briefly on antimony in the Caucasus, a subject matter early career researchers in my group have worked on over the past couple of years. Antimony is a metal interesting because it's long history of use, but usually it is sort of ignored in archaeometry or archaeology. It has been used for 5,000–6,000 years as a metal in alloys, in accidental alloying with copper, but also as a metal by itself, for instance, for buttons or beads. And of course, it's a very important material in glass opacification and glass decolorizing. That opacification in late Bronze Age, Iron Age glass, and then as a decolorizer in later glass making. Where do we find antimony? In alloying, mostly in the Caucasus, which is handy when you are presenting on that subject area. There is also an independent use of copper, antimony, arsenic alloys in what is Tuscany in Italy, but that seems to peter out, die out by itself and not be taken up again. Looking at metallic antimony objects, we basically see the same distribution pattern from the Chalcolithic on up to the Bronze Age, Iron Age, and there the Caucasus, Black Sea region, east coast thereof seems to be very important. Now we're talking mainly about this type of material here, core-formed vessel glass. In this case, the Amarna period from Egypt, very well preserved from grave contexts there. And antimony is used in those materials to opacify the glass. And this is intentional. One wants really those strong colored opaque glass materials. Yellow is lead antimonate, white is calcium antimonate. The blues are made with copper and cobalt, but also antimony is added to make that very strong colored opaque production. And we've discussed elsewhere, together with Andrew Shortland, good colleague from Cranfield University, how these Egyptian and Mesopotamian productions are different, how the Egyptian palette of production uses many more colors in a more standardized way, with a lot more options there to make this beautiful late Bronze Age glass, while Mesopotamian production seems to be a bit less standardized, less evolved, which has led to a whole debate on who was first, where was this first glass innovation, this common use of opaque Bronze Age glass, where was this started and who followed, but that's not for today. What we want to talk about today is the antimony. In this glass making, where would this Mesopotamian versus Egyptian production get its antimony material? And we can provenance this glass, one of the major ambitions of archaeometry, I would say. And we don't need to use very advanced techniques to do that. Trace element analysis, which we can do by laser ablation, ICP, for instance, can show typical elemental patterns for Egyptian versus Mesopotamian glass. And what you see here is that these copper-colored ingots of glass from the late Bronze Age Uluburun shipwreck found off the coast of Turkey contain Egyptian glasses. What we're trying to do here is, where do they get their antimony? What are the possible mineral resources? Which material is suited? And there it appears that stibnite, antimony sulfide, is actually the only relevant source of antimony that we can use for this ancient glass making, this late Bronze Age glass making. There are other minerals that do contain a lot of antimony, like tetrahedrite and others, but they usually bring in very high quantities of other elements like copper, zinc, lead. And for glass making, you cannot control that recipe anymore. You cannot control that strong colored opaque nature of the glass. So stibnite is the only relevant mineral that you can use. There is native antimony that does exist in native metallic form in nature, but it's very, very rare. So the only possible source, basically, the possible mineral resources we need to characterize are stibnite resources. The way to do this, how we approach this, is to use antimony isotope analysis. So we're looking at the ratios between antimony isotope, which may vary between ore sources because of the varying oxidation state, various geological formation process of the ore. Now, what is usually done in isotopic analysis in archaeometry is to compare the signature of an ore and compare that of a metal, or of a raw material mixture and compare that to an artifact. And then we presume that that signature, that ratio between isotopes, is unaltered, that it is identical from the ore to the material. Now with antimony, and we've struggled for a long time with this is not the case. In technological processing, in the process that you would use to use antimony as an ore in glass making, the antimony isotopes will fractionate. They will change because of that technological process. Even in our chemical measurement in the lab, they might change as well. So we need to, have control over that process to be able to model that fractionation, and then we can compare ores to materials. Now, it took us quite some time to model that. And so we have a correction factor. We did this through thermodynamical modeling, through experimental archaeology, basically imitate the technology and see how much it changed. But I've been giving this talk for some time now, saying that, okay, somebody else needs to check this, because in our lab, we did one experiment, or a series of one experiment, but under the same conditions. So we need to know whether we are right. Well, in the meantime, 2 other labs have done this, and they seem to come up with the same result. So this correction factor for changing your isotopic ratio in ancient technology seems to be valid. So we can now compare ores, in this case from Raqqa, from Georgia in the Caucasus, to the metal beads that we find next to these sites, and where initially we saw no correspondence, which was pretty odd if you find these metals very close to the mines and they don't correspond. With this 3 epsilon correction, as we do here, this epsilon is basically a geological expression of an isotopic ratio. If we correct for that technological processing, we see that some metal artifacts do match the local ores, and archaeologically that makes sense, and now archaeometrically that makes sense as well. There are metals, metal beads, there are alloys that do not correspond very well with the ores that we find as stibnite in this Raqqa region. But we also see that these antimony metals do contain other trace elements and are fundamentally different. And so probably other types of ores were used to produce those metals. But we don't know which, we don't have sources thereof, we haven't analyzed them simply. The important thing is to compare the glass, this late Bronze Age glass, in its isotopic composition to the ore sources that we may have. And so we see that Egyptian glass, these last two columns on the far right, Egyptian and Mesopotamian glass basically have the same antimony isotopic signature. And so it seems that Mesopotamians and Egyptians use the same antimony source, same stibnite, to make their own glass. And when we correct for that fractionation, when we calculate back to the ore that would have been used, actually Caucasian antimony is the only ore source. Antimony from Raqqa area, from that district, is the only antimony ore source that we have so far that corresponds to that signature. So this would mean that Caucasian antimony traveled in some way to Mesopotamia and into Egypt to supply glassmakers with their antimony source. Now, this is interesting as both industries that used very different raw materials otherwise, different silica sources, different plant ashes as flux, likely different metals for coloring, use the same antimony. And that antimony, that stibnite processing might actually, these antimony mines might have been driven by the demand for glass. What is also interesting is that we see two types of metals with a different antimony isotopic signature. So while stibnite processing might be linked to glass making, other ore sources might be linked to antimonial copper industries, but that is something that we cannot prove yet. That is something for which we further need to analyze actually those antimony-rich copper ores. What we do find next to antimony mining locations is glass beads, and these all have that glass signature in trace elements and in isotopes of Mesopotamian glass. So while stibnite from the Caucasus might go south to glass industries, Mesopotamian glass is coming up north to be used there. We haven't found any Egyptian glass yet in late Bronze Age Caucasian context, which might be an interesting thing to look for as well. Interesting is also, but this is a hypothesis, that stibnite mining is linked to more precious materials mining, for instance, gold. And so the argument there is that yellow glass, which is lead antimonate in composition, is used as an equivalent to gold in glass making. It replaces, after a while, where gold is used, yellow glass is used. And this figures with the fundamental nature of what this glass means in the late Bronze Age. This is a precious material that is made in elite context in a very controlled fashion and is used together with precious stone, with precious metals such as gold and silver in this early exchange, in this early diplomacy. And so, for instance, in the Amarna letters, there is correspondence between Mesopotamian Egyptian kings demanding glass and glassmakers. This is a material that has magical ritual properties, that has this iwen, where the color represents more than merely a color. And so it would figure that the production and the raw materials of glassmaking is more linked to precious materials industries than the more common antimonial alloys, copper alloy industry. A slight excursion to a later period. When we initially did these antimony isotopes, we also analyzed Roman glass, much later in nature, and also a much different use of antimony. In those periods, Greco-Roman glass, antimony, oh, this is automatically shifting, sorry. In those Greco-Roman periods, antimony is used as a decolorizer in glass making. And so the nature of the material is different. This is a utilitarian material, a common day material, and antimony there is used as a decolorant. So very fundamental in nature. When we look at antimony isotopic compositions, also lead isotopic compositions of glasses and the possible raw materials for this antimony decolored glass, we're looking at very different sources. Spain might come into place, Romania might come into place, Slovakian ores. But again, what is common with this Caucasian production in Spain and Romania is that they might be linked to, again, gold extraction, to gold mines. And there is a link there that in future research we'd like to explore further. So the origin of antimony for the glass industries of both Mesopotamia and Egypt seem to lie in the Caucasus, in a particular region where stibnite mining is linked to gold mining rather than antimonial copper industries. Those associations would be different. That is debated still. It might be that stibnite extraction, certainly from the age of the mines and the regions, are driven by the demand for glass. This would be more of a pastoral activity, certainly in view of the location of the mines. This wouldn't be a permanent extraction, but something that would fit well with pastoralism, something that is researched further. We do find direct connections to Mesopotamia in material culture, not to Egypt yet. So look out for that Egyptian glass, should you have any in your excavations or analysis. And we do propose a very long-term link between precious materials working and industries, and a separation between utilitarian and precious productions, where antimony would fit more into that precious line. But that is something that needs investigation further and still. I think I will stop there, gain a bit of time, well within the 15 minutes. And yes, in terms of audio, I don't know what to do with questions, but I'll leave it to Elena to take over again. Thank you very much for your attention.
Thank you very much, Patrick, for this very interesting lecture. Does anyone have questions?
I have a question, and I'm writing in the chat box because I think that.
Can you hear me? I can hear you automatically.
Perfect. So I don't need to. Great. So I was wondering, when you mentioned that you use the ores while analyzing the archaeological materials, and these ores are coming from the geological source of Raja, right?
That's right.
Besides Raja, did you try to use the ores coming from Swaneti too, which is the west part of Georgia? And according to the historical sources, we have a lot of antimony coming from Swaneti. And like, if you try to collect these materials and build up the isotope data.
Very interested to get some. What we have in terms of ores now from that area is through cooperations. I've actually never been there. So one of my assistants has, I haven't. So if there are any other ore sources, gladly, we'll have them gladly. It seems that stibnite is more rare than tetrahedrites, these complex ores. There seem to be many more complex ores combining antimony with lead, zinc, copper, which would not be relevant for glass making, but we'd be interested in looking at them anyway, because we have those different compositions of metals as well, antimony, metal, and copper alloying, and it would be interesting to be able to separate areas. What I also find interesting in your question is that you say from historical sources, antimony would have come from those, but which sources are these written sources? Or
there is archaeometallurgy research which has been published in 2012 by Alexander, sorry, I forgot the surname, but I can send you. And he's mentioning and talking about the sources, and he's mentioning Swaneti and Raja, where you can find a lot of antimony and like stibnite itself. And also the geological survey itself by Adamia, done by 2024.
Okay, if it's stibnite, I'm very interested.
And can I also ask you, is this data what you build up, the isotope data? Is it accessible? Is it free access, or?
There is an open access publication. There are two open access publications, one in STAR, one in Chinese Geological Review, something like that. That's just out. The latter one is just out. They're both open access. So all the data, everything's there for anyone to, if you have an internet connection, you can download it.
Okay, thank you. Yeah. Thanks.
Yeah, So there is a question on the chat by Birgit Schör. So I have never understood how antimony can be used both to opassify and to decolor glass. Different processes involved?
So in opassifying, what you make is nanoparticles. So you combine the antimony in really crystals of calcium antimonate or lead antimonate, and they will reflect light and give you opacification and strong color. So there it's really a particle that you make in your technology of glass making. In decoloring, it's the oxidation state of the antimony, the atoms that are dissolved in the glass, which will take away the coloring effect of other atoms. So it's basically a different chemical nature of how antimony is used and a different type of reaction. So the first one is more as particles, while the second one, the decoloring, is more in a chemical oxidoreduction reaction.
Any other questions? So I have a final question, maybe. So the use of antimony as a metal for beads and so on, would you consider it as a consequence of the use of the beginning of its use for glass, or as an independent phenomenon? Because it spreads also in the late bronze, as I know.
Yeah, I think it's independent of glass. So I think it's easily discovered because it's an easy metal to make. It's a metal that you don't need any much advanced technology to make it, but it's also a quite useless metal. Metallic antimony is soft like lead, so in terms of ornaments, beads, jewelry, it is usable, but not in terms of any tools or technology. And so you would observe quite easily with high temperature processes that you can make a metal out of this stibnite. I doubt that it would be conceived as different from lead or from any other of those soft metals. But when, of course, the properties in opassifying and coloring would have been recognized, and suddenly it becomes useful when the glass innovation happens, when this material is an equivalent to precious stone, then it has its specific purpose, and that could drive more of a demand for stibnite. So I would see this in invention quite early on, but occasional and not recognized as a separate metal. In the glass innovation, yes, then it becomes a material that you would want for a particular purpose.
Yes, thank you. Then if there are no other questions, I think we can move on to our next speaker, which is Zahra Kouzehgari. So from Iran. She has a PhD in archaeology. Her thesis was about war and social structures in the western half of Iran during the Iron Ages. And she is presently associate researcher at the Archéorient laboratory in Lyon. So she was involved in numerous projects in field projects in Iran, specifically about the late Bronze Age. So Zahra, if you are there, the floor is yours.
Yes, thank you for this kind presentation, introduction. Okay, I want so first of all, I would like to express my deepest thanks to the organizers of this event. I'm not doing actually archaeometry, I'm working on weapon, and today I'm going to present briefly the primary results of one of my ongoing projects on the comparative study of weapons from Western Iran and Southern Caucasus during the late Bronze and early Iron Ages. So the relation between Iran and the Southern Caucasus region during the history, notably from the Araxes period, early Bronze Ages, by the formation of the trade networks in these periods, it's completely so attested by archaeological findings. But I want to talk about the late Bronze Age, about the weaponry. As we know, so by the studies done by Schiffer and by Maxwell Hyslop in 1960s and 80s, so we know that during the Bronze Age we had a kind of homogeneous weaponry tradition, and so in terms of morphology and technology, that it was shown by the presence of the flaring or flanked hilt daggers that they were cast in one piece with their hilts. But during the late Bronze Age and early Iron Ages, we have two distinct weaponry traditions in Western Iran. One is located, as you can see on this map, in southern Caspian Sea region, as well as some parts of northwestern Iran, and the other in southwestern Iran and in central Zagros in Lorestan and in Dian area. So the collection of this collection is composed of a group of daggers and swords that I call them just daggers with bar-shaped guards, as well as daggers and swords with crescent-shaped guards, that they are different in terms of their technology and their morphological characteristics. So I don't want really to go to the details. These weapons are completely depicted in the artwork of this period. As we can see, these three daggers located in the this daggers located in the, you can see at the right, they are composed of, again, the bar-shaped daggers with bar-shaped guard daggers, as well as the crescent guards, which are exactly the same represented on the three weapons on the Hasanlu gold bowl. So for these weapons have also been discovered from archaeological excavations from various regions located in Talesh area in southwestern Caspian Sea in Iran, in sites like Hasan Zamini, Chilakhane, Jurjik, Aghevlar, and Choula Dare and Shaharyeri, which is located at the central Ardabil region. So the similar examples are excavated from Azerbaijan, Talesh, in Lenkoran, Veri, Hivri, and Tulu, and I know that there are numerous examples of these swords and daggers which are in these typologies. So this map shows the distribution of these crescent guard and bar-shaped guard daggers from sites in southwestern Iran, as well as to the Veri and Lenkoran regions, and Ardabil, like Shaharyeri, in northwestern Iranian area. So these similarities is not only limited in the weaponry tradition, but we see in the artistic representation or in archaeological characteristics that we can see as like the three weapons depicted in some ceremonial among some ceremonial contexts, like features on Hasanlu gold ball, as well as the silver beaker from Karasham, although the details of these two are different. For example, the daggers on Hasanlu gold ball, they are represented with their pointed downward, but while in other, for example, in Karasham, they are seen with their upward, their down upward are presented, and their morphological characteristics are completely different. At the same time, in the ceremonial, in the context, they appear here is a warfare varying context, but we see that this culture has been continued throughout this period. A few later from that period, that we can say in a transition period, we have other group of daggers and swords which are known as the open work hilt daggers. So they are composed of very short daggers generally with their hilts, with their open work hilts. Generally, they have these bar-shaped guards and heavy blades with prominent midribs. There are some examples, as we can see here. They have their differences, very small differences in their detail, like, for example, the form of the orientation of these triangle openworks on them. And we have other examples from archaeological excavations which have been discovered from northwestern Iran as well as in Talesh area. These two examples, which we can see them in Shoghula Dare, and this examples, very rare example, which have been excavated in southern Araxes River in Khodafarin, in Larijan Kurgan, in Khodafarin Plain in northwestern Iran from a kurgan. And this hilt from Marlik, which is open work hilt made of bronze, and we can see that the traces of iron oxide here, and we know that this was made of, which is attest indicate that this dagger or this sword, whatever it belonged, it was made of a kind of bimetal with iron blade and bronze hilt. So these examples come from, again, the similar examples with some very very small detail differences we have from Armenia, from the Legion, from Tazekent, from Arctic in Shirak province, as well as a very rare example from archaeological excavation in Kishlak Ramit in Tajikistan. So the geographical distribution of the second group of daggers, which are generally located in the southern Araxes River, as well as in the southwestern Caspian Sea in Iran, in Amlash, Moalik, Hashtvar, in Shoghula Dare, in Tazekent, as well as the regions which are located in the Armenia, then in a really vast geographical area. Although the examples from archaeological excavations in northwestern Iran are very rare, but the examples from archaeological excavations in this region, especially notably around the Lake Sevan in Armenia, they are numerous. Another group of, again, these kind of daggers that we can find in Iran and in Southern Caucasus, with Southern Caucasus parallels, are composed of these heavy blade daggers or swords with probably an organic grip, and with an open work pommel that they were attached to, as I told, to an organic grip, which is now lost. We have three examples of these daggers excavated in Larijan kurgans, again in southwestern Caspian Sea region. So these, unfortunately, the results of archaeological excavation in Larijan kurgans, they has not published yet, but some of these objects have been published in Ali Reza Kouchi PhD thesis. And we can see very similar examples of a heavy blade daggers with open work pommel, which are excavated in numerous sites in Southern Caucasian region. These are, I call them Southern Caucasian or Transcaucasian type weaponry, because there are some differences in the naming of these objects. Sometimes they call Transcaucasian weaponry, sometimes they're called from Khojale Gadabay, referring to the regions that they have generally discovered from mainly from kurgan structures, as we can see in southern Araxes River in Iran. So there are numerous examples, again, illustrated in museum all over the world. And according Nagel, Nagel has studied this in, I think, 1970s or 1960s, sorry, 1980s. And I know that he has classified these daggers according to their blade types and according to the decorations of these open morgue pommels that they have. And they can really be classified into different categories. But we know that there are numerous examples excavated or attributed in the museums in Nakhchivan, in Azerbaijan, and most importantly in Georgia and in Armenia, along with other types. Rather than so these daggers and swords, we have a group of heavy battle axes with their crescent blades, heavy crescent blades. Some of them weighed more than 2 or 3 kilos, but we have some examples. They are excavated from Southern Caucasus region or Armenia region. We have again a similar example of these heavy battle axes excavated from in Kuban 8 in Larijan, again in southern Archéorient region. Further to that, in these daggers, we have a kind of heavy battle axes with blunt blades, which are again excavated in regions in Tule Gilan, again in Iranian Talesh area, and with Khoja Daoud Köprü, which are similar, and there are numerous examples of these from archaeological excavations, again in Transcaucasian areas. So we have very similar arrowheads that we can know by tanged and barbed arrowheads, which they are very effective and very pointed examples. These traits that I have studied in museums, they're really effective weapons, and according to their morphological characteristics, they have a very interesting, very important aerodynamic characteristics. So they could pass a long distance when they were used in the ancient time, and at the same time they could create cause very deathful injuries when they enter to the body of their deceased. So we have examples excavated from Marlik. Numerous examples of these barbed arrowheads are now in Iran National Museum in different sizes. Some of them are really heavy, and while there are very numerous examples which are very light and pointed examples that we have more than, I think, 20 or 15 kilogram of these kind of arrowheads in Iran National Museum that we studied in our project in 2019. So again, some parallel examples from Tule Talesh in Iran, and again in very Azerbaijani Talesh and Namin, again, which is a site located in central Ardabil area in the place between joining again the Talesh area to the Ardabil center. So these collaborations provide us very I think invaluable information concerning the subsistence economy, or maybe their settlement patterns of these people. So the burials, the major of these objects came from this weaponry. They came from, for example, in Chilekhane, Sulidere, or in Qale Sange-Molk that we can see in northwestern Iran, as well as in Talesh area in Iran and in Azerbaijan. So they are the so-called Krumlich kurgan structures with a megalithic grave on the surface at the center, and with their with a circular structure made of stone, or generally stone stelas that we can see on them. These kind of kurgans are again present in northwestern Iran, as well as Zardkhane kurgans. As you can see that very small, very large megalithic stone structure or dolmen, and is surrounded by a circular standing stelas from this region. These kind of burials are generally associated with a kind of military architecture made of, or hills, they're called hills. They are constructed of undressed stones. They set over without mortar over each other to construct the fortifications inside the structure, as well as their outer walls, surrounding walls, that they are, on the basis of their architecture techniques, they are dated to the late Bronze and early Iron Ages. This is not only Zardkhane, and we have, according to De Morgan, we have again the Namin. As you can see, again the distribution of their Cromwich Kurgan burials, as well as the fortification which is located at the top of this mound, or this rocky mound that is again a stone structure, hill fort that we call them. So we have different structures, as you can see here, of these objects, and that it starts from these from southern Caspian, from western Caspian Sea region in Iran as Namin, so near Boigneron, in Meshkin Shahr, Ahar, or the Varzeron, which is like Kigal, Sangemok. Unfortunately, most of these Kurgan sites, they have been excavated through, they have been known now through archaeological surveys, not archaeological excavations. So we can't really say more about that. But according to the surface surveys that was surveyed by Wolfram Pleiss and Stefan Kroll in 60s, 70s, and 90s in decades, and as well as so the examples that were excavated, like Zardkhane, which is one of the rare examples, they demonstrate again a kind of relation with the people of the late Bronze and early Iron Ages, which are located in this region in central Ardabil, Ahar, Barzegan, which is a rocky or a mountainous part of this region, with similar kurgans which are associated to hill forts. And from these again burials, we have the similar Transcaucasian or Southern Caucasian weaponry types, that the most of them we can find them in Armenia, according to the studies conducted by Adams Smiths in this region. So these settlement and distribution patterns of these kurgans and the associated hill forts, there is something that we can see in the Armenian area, notably around the Lake Sevan, as well as some sites in Azerbaijan and in Nakhchivan. But what is important, this information provide us with with valuable information, I think, about the Iron Age of the northwestern Iran, which was previously limited to the Hassanlu publication project, and we knew most of the chronology, typology, and the culture, the culture from the southern, notably Urmia Lake Basin and around the Urmia Lake Basin in northwestern Iran. But we have never known what happened in this region, and we didn't have any information about what happened during the late Bronze and early Iron Ages in the eastern part of northwest Iran. Now, this weaponry tradition, as well as a part of another study that I conducted about the kurgan structures in northwestern Iran. So this provided me with information. This has shed light on these people who were settled, and about their cultural interaction with this area, as well as their pottery traditions, their burial traditions, their architecture, and their weaponry and metalworking traditions here. So during the Iron Age early phases, Iron Age 1 and Iron Age 2, in northwestern Iran, again, we have two distinct realms of weaponry culture. So the first is composed of daggers and long swords made of bimetal, we can call them bimetal swords and daggers with their long iron blades and their bronze hilts cast onto their tanged blades. As their morphological characteristics differ from each other, but in general they are composed of but their general production techniques are the same. And we can see, we can see here, these bimetal swords with bronze hilt and iron blades are excavated by Dumorgan in Çoğuladere, again in Iranian, in Persian Iranian Talesh, as well as in these two examples is traced in the museum, Iran National Museum, which are associated to come from northwestern Iran. So the similar examples with similar morphological characteristics that we call them ear-lobed pommels with horned guards and with long iron blades, which most of them lost because of the region that they were oxide in the soil. So we have examples like Ani, like Mechart, like Salka that they have excavated in Southern Caucasus region. And these are again another group of these daggers and swords, again with bimetal, with blades and iron blades and bronze daggers, again from Tule Talesh, from Çoğuladere, with similar, as we can see here, the different pommel shape as well as their guard forms. But they are their general characteristics are the same. So in terms of belts, again, from the northwestern Iran, we see two distinct cultures. So in terms of their decorations, their morphological characteristics, like their ends and the motifs that they have been used to decorate them. This is an example published by Sulijan, Ursulikan and Zimmer in 1987. So this is a Transcaucasian type belt, as we can see, but this is said to come from northwestern Iran or from Ardabil, as well as this example. So this is completely Transcaucasian belt type. So in terms of its form and decoration and iconographical characteristics that they dated to about 9th to 8th century BC. So we can again compare this example, its iconography with the Transcaucasian belts, which have been published by different archaeologists, scholars. The other group of belts that we find them in Hasanlu region, they are not directly Transcaucasian objects, but as we can see in terms of their form and some kind of their decorations, they are, or as Magan Cifarelli and publishes in copper alloy belts at Hasanlu in Iran. So they see that these cultures, these belts are derived or inspired by Caucasian examples, but they are made in Hasanlu. They're a local made according to their decorations as well as to their forms. So these examples, again, we can compare them with the form of their end form, their decorations, so the framing of these, so the surface of these belts, and we can see, again, we can compare by examples which come from Southern Caucasus region. So these two examples, again, are from belts, bronze belt from Çoğuladere, that they are completely different from the belts that we found in Hasanlu because they are completely different, so decorated exactly or very similar to those that we can see in in Hasanlu and we can see in Southern Caucasus region. And we refer to the last example, which is again one of the bells produced in Hasanlu. Instead of these incised dots, they have used so a kind of dots in creating these dots resemble to the Caucasus region, to the Caucasus weaponry. So these are known as Caucasus weaponry type, but not Caucasus weaponry. So they're completely different. And as we see that during the different regions, different periods in different regions, we have different kind of, so this Iranian and the Caucasus weaponry, we can't really associate them, their beginning, their morphological, their characteristics to any of these regions, because I think we need to study more and to have more examples with carbon dating. So from carbon dating context will in the future will shed more light on the emergence of the development of the late bronze and the transition to the Iron Ages, notably in northwestern Iran, and the interaction that this region had with its adjacent areas in Southern Caucasus region. So as I told, this is a primarily result of an ongoing project. I know that there in museums in Georgia, Armenia, in Azerbaijan, there are numerous examples of these weapons that they are, I think, not published or are being studied right now. And I wish really one day to have the chance to access this material to fulfill my study. Thanks for your attention, and questions and comments are welcome.
So thank you, Zahra, for this very interesting talk. I think it's really important that this area of northwestern Iran is fully integrated in research about the Southern Caucasus, because there are numerous links, especially in the late Bronze Age, but also in the Kura-Araxes period. So it is really a topic on which we should concentrate in the next future. So do we have any question? Can you close your presentation so that yes, I can see the questions. No question?
I can go for one question. So what do you think, Zahra, from all this research, or from all the comparisons from the different areas, like in terms of technology of the weapon, do you think is it local, or if it was influenced by the adjacent regions, or
so in each type of weaponry, we have different, techniques used. I couldn't really talk about to go into detail within this short time, but it depends on the weapon tradition. For example, in Hasanlu, when we talk, we have the remains of a workshop, of metal workshop, where they were producing this, making these weapons. We have there the molds, we have different things that we can conclude that they were making this weaponry during the Iron Age too in the region. But about the weaponry that we can see, the open work hills, we don't have very earlier examples in Southern Caucasus, while we have in southwestern Iran the earliest examples of these open work hilt daggers. They developed in Haftepe, and we have found their traces, the molds, in the workshops in the region from archaeological sites during the early Middle Bronze Age, not late Bronze Age. But we know that this developed in southwestern Iran, and it continued in northwestern Iran as well as in Caucasus region. But I think there are the objects that they so despite their importance, despite their quantity, they have not been studied very in detail.
Like, I don't know if you're familiar that in Georgia we have this Kolkhian culture. They produced the axes with different kind of motifs and ornaments. Like they use a lot of animal motifs and like it's dated late Bronze Age. I don't know how it will be relevant for your topic, but as a comparison, it might be useful.
Yes, I know. But since this example of daggers that have not found in Iran, I didn't mention them. They're a very large group of daggers with heavy bronze works, which is interesting. And most of them, for example, on daggers, we have on the blades, instead of midribs, we have the snake motifs. And I suppose most of them, they have the symbolic significances. But since they were not discovered from Iran, I couldn't mention them according to the topic of my study. Yeah.
So,
thank you.
Thank you. I think we are a bit late on our schedule. So if there is no other urgent question, I would propose to go on to our next speaker, who is Professor Ruben Badalyan. Professor Badalyan actually doesn't need any introduction. We all know him, but I will say a few words anyway. So he's the head of the Institute of Archaeology and Ethnography in the National Academy of Science in Yerevan in Armenia, and he was teaching in Yerevan State University and as visiting professor at the University of Chicago. He is and was leading numerous archaeological expeditions in Armenia with foreign colleagues from France and Germany, and his areas of research are the Neolithic, Chalcolithic, Bronze and Iron Age of the Southern Caucasus. He was especially active in research on obsidian, and he will talk about, in fact, about obsidian in the Southern Caucasus. So, Ruben, the floor is yours.
Thank you very much, Elena. Thank you, Magda. I really like this topic. It was in focus of our interest since 1986, when with my friends and colleagues, Zalki Kodze, Philip Cole, and James Blackman, we start the first precise investigation of the Caucasian obsidian. Since that time, a lot of articles was published and a lot of works were done on the different subtopics of the obsidian. That's the technology, that's the geomorphology, that's distribution. And I want to share with you some last information, what was done during the last 10 years in this field. First of all, that's a new geological and geochemical description of some volcanoes which produce obsidian in Armenia, in Turkey, in North Caucasus, and in Georgia, Azerbaijan, and again in Armenia. That's Shikiani, that's Kerbajar, that's Zayukov and Baksan on the North Caucasus. That's a publication about investigation of the specific sites in different parts and in very different chronological diapason. For example, Neolithic assemblage from Aknashen, or article about Gegarot early bronze material, especially now our Iranian colleagues very active in this field, and we have number of articles in different geographical and chronological forms, especially about West Azerbaijan, Iran. Last publication in this field, especially about circulation patterns and how was the communication network from the north of the Caucasus until at least Urmia Basin. Last time we tried to summarize the results what we have so far. I mean the article which is preparing with Chatenier, Barsh, Melik-Sechan and Pernitska, and which I hope will be published soon, where we summarize the results of analysis of almost 9,000 obsidian artifacts from the stone, bronze, and iron age from the territory of Armenia. But in short, I want to introduce you very short how was the history of the using of the obsidian, because in the lower Paleolithic time, obsidian wasn't a very popular material. It was quartz, it was a tufa, it was andesite, and only in the late Archaeologian time we have a predominance of the obsidian, which continue until the end of any archaeological era. In any case, in the central part of South Caucasus, because Black Sea and Caspian littoral, the population of that areas prefer and use more flint. But in central part of the South Caucasus, from the Paleolithic until the Iron Age, obsidian consists 90 or even more % of the lithic material. During the Neolithic, when it was a period of the flourishing period of the obsidian in industry, when at least three different techniques of the using of obsidian we can observe, both in the basin of Kura, in the basin of Arax River, but during the early Bronze Age, we observe already the degradation of the obsidian blake industry, starting the Chalcolithic period, and during the early bronze and I think late, middle, and early iron, practically we tool production from obsidian, it was just ad hoc rather than industrial scale. Predominate its flakes, its using of flint for especially sickle blade, just few example made from obsidian, and this tendency continue under the until the disappearance of obsidian artifacts from any archaeological complex. Couple of words about different form of the using, not only tool and weapon industry, but using, for example, obsidian in the funerary ritual. For one of the best examples, it's for me in Ibitum in Gerarot, where was a natural block of obsidian, almost 9 kilos, put in funeral assemblage. Using obsidian as a jewelry, it's not very popular in South Caucasus, maybe because of the abundance of the material, but I will show you some interesting examples when gold and obsidian working together in one piece of the jewelry, like pendant from early bronze level of Shengavit and bead from Middle Bronze Age kurgan of Aruj. Other interesting aspect of using obsidian during the Bronze Age, Chalcolithic and Bronze Age of South Caucasus is that so-called vessels with a window, where in the bottom of the vessels a piece of the transparent obsidian usually put. The earliest examples coming from Ali Kemek Tepesi Chalcolithic settlement, but continue after early bronze in some Shvilde. Very interesting in Velikent, because Velikent belongs to the zone of the flint industry, mostly that's Caspian part of Dagestan, but until the Iron Age. Finally, obsidian in pottery production was used as a temper start from the Chalcolithic, at least Chalcolithic period until the late Bronze, early Iron Age. You can even visually see the pieces in sleeves of Neolithic, even Aradashen, early Bronze Tzahgasar, early Bronze Gegarot size, and some articles which was recently published by our colleague. And two words about the geography. So except North Caucasus, where we have Zayukova and Baksan in near Elbrus Mound, that's Chikiani on the territory of Georgia, Agvorik Sizavet, which is very small outcrops, Artenim, one of the biggest volcano on the territory of Armenia, system of the volcanoes on the Tsahkunyats range, Geram range, Horapur, isolated volcane, and one of the richest area, that's the Sunik range, with the Satanakar, Sevkar, Bazeng, and other volcanoes. So we have on the territory of Armenia so far registered more than 500 volcanoes, but just 20 of them produce obsidian. That's very different in terms of geochemies, and of course different in terms of how this raw material was used during the Bronze Age. North sources like Agvorik and Sizavet, interesting just in terms of geochemy, because two sources in the distance of 7-6 kilometers between, but produce very homogenic raw material, because that's Metz and Poker Arteny, where we have at least 3 main chemical groups. Other example, that's Gutansar volcano, which cover a huge area, more than obsidian cover a huge area, more than 20 square kilometers, but that's very homogenic material. And Lusavan, Gerard, Berfontan, and many other small outcrops produce geochemically absolutely and identical material. Hatis volcano on Geram range also produce obsidian of two different chemical composition. And the biggest, richest, and more active may be used the system of volcanoes on the Shunik zone, where Bazeng, Metsatanakar, Metsevkar, Poker, Sevkar obsidian produce obsidian, which, as now we know, thanks to the series of analysis, it's obsidian which was in 16th differentiated by Renfrew and his colleagues as obsidian of group 3C. The results of our last investigation, when we summarize analysis of more than 65 settlements of Armenia of different time, was a focus on the two specific periods, that's the Neolithic and Early Bronze. From the 4 Neolithic settlements, totally, we investigate more than 1,300 samples by the different methods, neutron activation analysis, XRF, ICP-MS, which give us possibility to understood in the very general reviews how was a system of the distribution of raw material and using of these sources. Here we concentrate only on the Ararat Valley because it's the main area where we have more or less investigated Neolithic settlement. What we can constatate that each site, each settlement using 6, 8, or even 12 different sources. Source not only in immediately we can see like 40 kilometers, it means 1 or 2 days of walk, but very interesting also source in the west part of Armenian highland, like in Sarikamish, Erzurum, passing their area, also lake. One source is like Meydan, Nemrut, and Bingöl. Material was very popular on the territory of Arax and Kura basins. Of course, one, and as usually nearest source, was a main, like in our case, in case of Akhnashen, it was Arteni, which produced almost 50% of the raw material, but also other sources which are located very far. So, for example, in total in Ararat, for the Neolithic sites of the Ararat Valley, we have Arteni as a main source, Zakunyat and Geram region, which produce twice less, almost 20% of the material, very few Gerasar, and interestingly, Sarikamish, passing there, Yagli Jadak, together with the areas from Bingöl until the Meydan Dak. Interesting that it wasn't economical reason for these sources, because they produce only less than 3% of the total raw material. But the same situation we observe in other Neolithic sites in Kura basin. The archaeological problem here is that we know nothing, unfortunately, about the Neolithic culture in area of the upper part of Arax River from passing there to Yagli Jadak, and we don't know what was the reason of this connection. It may be a little easier to explain in case of Bingöl, Nemrut, and Meydan Obsidian, because on the settlements of Ararat Valley, we have relatively big collection of the import Samarra and Halaf pottery, which is geographically linked with the area where located the most north settlements of Samarra and Halaf sites. In the case of the Kura Arax, where also more than 300 samples analyzed for 32 settlements of the different areas. We have well investigated two areas. That's Arad Valley in the center of our interest, because Arad Valley is the central part of Armenia, relatively far from the any obsidian source. And here, really, we can see how the territory of this part during the Kuraras divided by the 2 or 3 main areas. First, that's the sites on the west part of Arad Valley, where 60, 70, sometimes even more obsidian coming from the nearest source, which is Arteni. In the central part of Arad Valley, more than 50% of material come from Gutansar and Hatis volcano, and eastern part, including part in Nakhichevan, used obsidian of Gerasar. So what is interesting and maybe natural here, that's any settlement of Arad Valley used obsidian from 3, 5, even 8 source. Always in the case of the geography of Arad Valley, it's always possible access to the alternative source. But on the other neighbor area, like Shira Plain on the north west corner of Armenia, we can observe also not only the domination of the one specific source like RNA, which is, but also the down of line model, which is coming from Near East and going back, but also the so-called single source model, when the sites just near the source don't need other material from other sites. So it's not always easy to understand what was the logic, because the quality of material more or less similar everywhere. What we can say after the result of GIS analysis of the Kura-Araxian sites and obsidian source, that it wasn't spatial control by the volcano. Metal, yes. We have evidence for the control of the road and source of the metal. But source of obsidian, as I understood, was in mostly in the open access. It was examples from the different part of Armenia. But the same situation we can observe also in the basin of Kura, to the north and to the east of Armenia. And what is more interesting, so both models, single model, multi-source model, working from the Neolithic time until Iron Age. So maybe that means that geographical distribution was the main, of course, was the main reason for the use of the source. For example, but again, here's some interesting samples, like in Georgia, for example. Look, many sites of the Neolithic, early bronze and Neolithic, using the obsidian only from the Chikiani, so nearest and richest obsidian. But some Neolithic sets like Chramis Didigora, and according to the last investigation of Gratus and Rova, like Archaeologic Citeli Gorebe, or ignored this site, or using more material from the south part of the Central Caucasus. Also, Chalcolithic level of Mentesh Tepe. 64% of material coming from the Geram range. And again, you can observe here material from Sarikami. So again, western directions, which unfortunately given us any information about the cultural connections. Other vector of the relations, how was used those Caucasian material out of our area? Strangely, but we have less investigation in this topic, but in any case, what we know, that's good. First, the earliest example of the distribution of Armenian material, that's the Neolithic settlement in the lower Dnieper. It's more than 1,200 kilometers northwest from that's again theme Troy and related settlements on the islands. What is interesting in this direction, it means that material from Gutansar next to cross area with Erzurum passing there, the central area which reached by the local material. Galata and also Melos in Aegean Sea was a very useful source. But in any case, we have a couple of samples in Troy, in Venice, Badalyan, more than 1,600 kilometers far from the source. Arslan Tepe, Tel Zeydan also used in the very low number, but in any case, obsidian from Artenim. And finally, Talimalian in southeast direction. In the end of the second millennium, used material from Punic source. The last evidence for the distribution of Armenian material, that early bronze site Velikent on the Caspian littoral, which population of which used practically only flint, but in the same time, some pieces of Chikiani, Arteni, and Gutansar obsidian were found there. So to conclude the results of this investigation, I can see that for the moment we have, I think, complete list of obsidian deposits on the territory of Armenia, investigated by different precise analyses. In terms of the archaeological investigation, more than almost 9,000 artifacts of the stone, bronze, and iron age investigated. We can understand how was the role and significance of the different sources in terms of utilization, where was a local, regional, transregional vectors of the distribution of raw material, main, secondary, and occasional deposits in the list of our sources. But still, I think we have a lot of especially geological work to do, especially geological, geochemical work, because so far in the total corpus of our investigation, we know the source of 93% of the investigated artifacts, and still 7% of material need to be found on the territory of South Caucasus or neighbor regions. Thanks a lot to organizers.
So, thank you, Ruben. Can you switch off the presentation? Yes, thank you very much for this impressive synthesis on several decades of research, which is by now giving some general pattern, and this shows that this kind of analysis needs time. And an interesting result, I think, is that South Caucasian obsidian were also used and were part of a wider network involving the Near East, which until a few years ago was not clear, was not very clear. So I think this is a very important result. So I have there are some questions. One question on the chat. In the meanwhile, if anybody has questions, please prepare yourself. So there is a question by Gia Chilingarashvili. So, Professor Ruben, you mentioned several sites, but I didn't understand them. Are they EBA sites? Could you please tell me if there are any examples of vessels with obsidian windows from Armenia during the Kurar access?
During the Kurar earliest evidence, that's Georgia, that's Samshvilde. From the territory of Armenia, earliest, that's the Middle Bronze Age. That's Karashamp and Horom cemeteries. It was a question.
So I don't see any other question yet. So I have another question about these vessels. Do you have any hypothesis about what was the meaning of this obsidian window, let's say?
First, I can't answer. No, I haven't idea. I can describe the situation. So first, all the vessels were found only in funeral context. As far as I know, all the obsidian is transparent. You know, the obsidian is very different, but everywhere always was used just very thin piece of the transparent obsidian. And first archaeologists who found this vessel Samshvilde describe it as a vessel for drink during the sacral ceremony. The part of the material found occasionally, so wasn't special investigation of the what consists the vessel. Unfortunately, I don't know this experience of that. But Guram Mirskula's explanation, I think, more useful. Some special sacral ritual.
So there was a comment by David Berikashvili who confirmed that there is a so-called window pottery from Samshvilde excavation. So I would like to add, among the other uses of pottery, maybe something that can be connected with these ritual uses, which is the obsidian eye insert on the eyes of some Kurar access or bedeni, better bedeni, earth protoms, and ritual reliefs. So these zoomorphic or anthropomorphic protons have sometimes obsidian eyes. So this points to some deep symbolic meaning, but of course it's...
Rabaji Shengavi is the best examples of this.
Yeah, that's our goal as well. So Other questions? I see none. So should we go on to the last but not least speaker, who is Mark Iserlis, presently from the Deutsches Archäologisches Institut in Berlin, but originally from Tel Aviv University. His research focuses on the prehistoric and protohistoric ceramic technologies in the Caucasus and the Levant. He has headed with Yotam Rotem the research at El Yakush in the Central Jordan Valley since 2018, and since 2022 the Lower Karabakh Research and Excavation Project with Alba Medov. So are you there, Mark? Yes.
Yep.
You can start, please.
Yeah, this is like go to the forward. I mean, a few slides, if you can go. Yeah, like this. Yeah, this is okay. This is okay. So the next one, after, like, if Gwen, if you can go forward. Next one. Yeah. So I just want to remind you about these questions on connections with the Aslantepe or with the Maikop pottery industries. Anyway, the next one, please. Pottery, the most frequent and important, from my standpoint, find at Ledatepe sites, was treated pretty randomly in the field and in publications. So I think that a description and definition of Ledatepe material culture, and especially its pottery in contextual context, is very important. I mean, we can't actually discuss Ledatepe without describing its very basic material culture, especially pottery. The next one. I think that we have two very basic questions. One of them is what is actually shared in the technological behavior of all the Ledatepe pottery producers and users, or there is nothing shared, and then we can't actually describe different sites and different assemblages as of the Southern Caucasus as belong to one cultural phenomenon. To answer this question, I started this project on Ledatepe pottery technology, and the first stage of the project included actually 3 sites: Berkel-Deybi in Georgia, Ledatepe in Azerbaijan, and Alhantepe in Azerbaijan, a bit to the south, actually pretty southern part of Azerbaijan. The expectation was to identify the basic technological principles of potters in different settlements, and to discover or disprove actually the connection between potters from different sites and regions. In other words, to try to identify if we can tell that potters from Ledatepe are producing pottery in the same way used by potters from Berkel-Deybi, located pretty far. The next one, please. The study is the next one, Gwen. The study is based on a pretty broad qualitative sample of excavated sites representing different geographic regions and geological environs. It is based on first-hand observations of material, raw materials and of sites. And normally I sample the pottery from well-stratified contexts. It is based on a very specific ceramic sampling protocol. It includes potential raw material samples, mineralogical analysis, data creation of a sort of wide database, a reconstruction of ceramic Chenepratoire, and radiocarbon dates, because Lelatepes sites are one of the problems with these sites. They are not well dated until now. I hope we will solve this problem slowly. So next one. Diagnostic sherds and vessels from 3 Lelatepes sites, and I mean Lelatepes sites, Lelatepes in this case is the name of the phenomenon, not of the geographic location in Karabakh steppe, were described. A technological database containing 260 samples was constructed, and the database includes visual observations and descriptions, photographic database, petrographic slides and observations, and as I described previously, raw material sampling, including plasticity tests and like a broad experimental work. So the ceramic assemblages from the Lelatepes settlements consists normally of 2 main typological and functional groups. The first one is the non-kitchenware or table and storage in terms of function. It is mainly tempered with chaff, and this group includes normally 2 subgroups. One, and the biggest one, is pretty rich in chaff. The second one includes a very small amount of chaff, but still normally includes sometimes very rare organic material traces. The second group includes coarse kitchenware. You can see it on the right side, fragment of a skillet from Berkel Davy. The next one. Additional example is the next one is Gwen. Next one, yeah. This is a sort of demonstration of how does it look like. Non-kitchenware is that is around 60 up to 70% of the ceramic assemblage. Consists of creamy orange to yellowish polished or slightly burnished pottery made of a very specific clay, also visible without any instrument. The cooking pot, the kitchenware pots are mainly made of a bit coarser clay, brownish, blackish, many times polished or also slightly burnished. The next one, yeah. This is a typical table and storage ware component of each and every Lelatepe phenomenon settlement. It includes always a lot of vats, jars, and storage jars of different sizes on the right side, and up to 30 or even 40% of bowls of different sizes, including carinated bowls on the left side, in the mid of the bottom row of the column. This is a sort of marker of Lelatepe assemblages that always should be noted, and we have to think. I mean, at the moment you have these bowls, carinated bowls, it is a real Lelatepe assemblage. Next one. Yeah. So the notable and immediate observation of microscopic analysis was the clear segregation of raw materials used to create different typological groups. There is a consistent similarity in the technological approach taken by the Lelatepe non-kitchenware potters to their craft. Next one. You can see clearly, this is, for example, Lelatepe itself, the site. There is a separation in clay between the kitchen and non-kitchenware. The same is with temper. Next one. This is Aljantepe, the southern side. You can see clear difference between the preferences of the potters of the non-kitchen and the kitchenware. The next one. Yeah. The same is with the temper. And the next one. This is Perikildebi in Georgia. It works exactly the same way. Clear segregation in raw materials between the two main functional and typological groups. The next one. As usual, there is a segregation in temper used by potters responsible for production of different groups. The next one. Talking about the Lelatepe pottery production, we can talk about this similarity in the technological approach taken by the potters from 3 different sites located in different places and in different geographical and geological environs. In addition, you can clearly see that the non-kitchenware was produced with use of potter soils. We identified actually 6 different fragments of potter soils from Lelatepe, from Aljantepe, and the 2 stones were found at the Büyükisik in the northern part of, much more northern part of Azerbaijan. Next one. Additional thing that we can talk about is the very specific firing techniques used by the potters from different typological groups, and we are talking about use of pottery kilns by the non-kitchenware potters. In this case, you can see the potter's kiln found by us in Lelatepe last August. I can describe it as a typical Near Eastern or Mesopotamian kiln with described mostly, by the way, from the South Mesopotamian sites, but I saw also a few examples from the northern part, and I think also from Iran. I just forgot to check it if you like before the presentation. To sum up sort of like this presentation, next one. Yeah, table and storageware potters working with the highly organized workshop environment extracted local marley clays, adding artificial temper, mainly chopped chaff. The clay was of uniform quality, testifying to the priority placed on obtaining the most suitable clay. The potters added water to the clay and kneaded it well. This is attested by a unified matrix with a minimum of air bubble gusts in the thin sections. Potters used coils and mold technique to build the body, and the slow wheel was used for the addition of the rim and for centering the entire vessel. For the small and medium bowls, the potters used wheel coiling technique. The vessels were slipped and polished or slightly burnished. The vessels, as I told, were fired in well-controlled oxidizing atmosphere. And the result was a simple functional commodity of a typical color, pretty standardized, and as I told, simplified. This is the key word in this case. Cooking pots and skillets producers collect naturally tempered coarse soils from the environs, and they used also coils techniques, but they added to the clay really coarse temper. It was important to prevent from the vessels to crack during the use and intense use on fire. The vessels were never produced using potter's wheels, and they were fired in a pretty simple procedure, definitely non well controlled or something. The work of the local table and storageware potters is marked by the efficient and economic use of the potter's wheel, in contrast to the kitchenware, use of totally different clays, etc. And the next one. Continuing now excavations at Leylatepe, an additional site located to a bit more than 2 kilometers from Leylatepe, called Canavartepe, and processing pottery in a bit different way than it was processed by the previous excavators. I can tell that we see that probably normal Leylatepe assemblage, pottery assemblage, should include a bit more kitchenware than it was normally kept by the excavators. And the normal assemblage includes also a small, up to 1.5% or sometimes maybe 2% of very special, unusual, let's say, exotic vessels that they are not really typical Leylatepe non-kitchen ware or Leylatepe kitchenware. And we are talking about the burnished black or brown vessels. But this is question for the for the next step in our study. Next one, please. This is area west of the potter's kiln at the Leylatepe, excavated also last summer, and they suspect we maybe found a sort of large pottery pit with a lot of not really wasters, but broken vessels mixed with a lot of charcoals and everything and additional things. But the area was disturbed, heavily disturbed. So for now, we can't really talk about that seriously as a sort of part of the potter's workshop. Next one. Yeah, next one. Comparing, I always like to compare everything to Kourouraxis. We are talking about very different traditions and very different technologies. Leylatepe non-kitchen vessels are a sort of very specialized, very centralized, very simplified industry based on, at each site, on one or two clay sources. Chaff and fine sand is a temper, coiling and wheel coiling is technique, and well-controlled firing. At the moment that Kourouraxis is a sort of endless variability, use of grog that was never used by the Leylatepe potters, use of everything, including slabs techniques, but never use of wheel, potter's wheel. The only point is that in both cases, the pottery was produced very locally and the firing was very well controlled. The next one. Yeah, so thank you very much for, even with all these technological problems, technical problems. Yeah, and thank you for inviting me one more time.
Thank you, Mark. This is very new and really very interesting. So I think we need to digest it a bit, and we will have a lot of questions for you, but maybe someone already has questions now. Questions?
If I may, Bertil,
Yeah, sure.
I raised my hand, but it doesn't work. Can you hear me?
Yep.
Okay.
Yeah.
Hi, Mark.
Hi,
I just wanted to know, you spoke about this burnished black pottery, about 1 to 2%. This is in Arhantepe, but do you have the same in Leylatepe?
Yeah, we got, sorry, I wasn't clear, I believe. That was the question. Sorry, I interrupted you.
No, because just Narimanov never speaks about it.
Okay, that was really interesting. We found that in the storage in the Institute from the old excavations, and there were a few non-diagnostic. This is very important. They are never diagnostic sherds. And then we started with our excavations, and we found at the both sites. I mean, Leylatepe and Canavartepe, these unusual scherts, 1 up to 2% is the total of the unusual non-typical pottery. These scherts are up to 1% maybe, but yes, it's always appears and always at both sides in the good described and very sealed context. So this is not like intrusion or something. Yeah.
Okay, thank you very much.
Welcome.
We don't hear you. Elena, we don't hear you.
Elena,
Sorry,
you're muted.
yeah, so there is another question by Bianca Maria Danna, so please.
Hi, Mark.
Hi.
You spoke about dates, so you are waiting for C14 dates. Did I understand correctly? And about chronology, do you think that what you excavated at the two sites is contemporary? I mean, in terms of ceramic, of course.
First of all, we actually received new dates, and they are contemporary. The earliest date at the Leylatepe, and this is not the earliest phase. I believe it will be also like a bit earlier. It's a very beginning or of the 4th millennium BC. And maybe very end of the 5th, but this is only one date. The latest date at Leylatepe is the 37th century, based on our new dates. At Canavartepe is pretty the same, the earliest dates, but the latest date, and this is really surprise, is 36th century, and this is a sort of very tired Leylatepe. I mean, the pottery
Sorry,
is
didn't understand. Very
tired Leylatepe. I mean, the pottery is a sort of coarse. The shapes, the typology, the morphology is Leylatepe morphology. In terms of quality, this is not the best Leylatepe pottery I saw in my life, and so we are still in the first half of the 4th millennium BC. They are contemporary, but probably this new site, Canavartepe, exhibits a sort of bit different phase, a bit different appearance of the phenomenon, including pit houses and sort of shelters with also characterized by very different ceramic assemblage in terms of percentage, in terms of use. They use much more storage vessels than, for example, bowls. But in terms of technology is exactly the same. You can see this is still I have to work on it, but for now it looks like very the same idea, a bit different execution.
Thank you.
Welcome.
So, other questions? I don't know, maybe I didn't see some raised hands. I just checked, but I see none now. So if not, I think we can thank Mark and all the other participants and the audience as well. It has been really interesting and especially also there were some very recent and new information, especially by Mark. So we are all looking forward to seeing publication of this new data from Leila Tepe. And so if no other comments, I think we can thank everybody and send and say goodbye to all of you.
So I will.
So yeah. So you.
No, don't worry. So I just want to say thank you to everyone from the side of the Caucasus Through Time Network. Thank you for your time. Thank you to all of the speakers and researchers and the audience, of course. And if you are early career researcher and if you would like to share your research, you are more than welcome to contact us, and we will open for you the platform. Also, you can contact us through the Twitter, Facebook, and email address as well. And we are searching for the young volunteers. So if you are willing to join us, you are more than welcome to join our new committee. Not new, we are existing already 3 years, but still, so we will be happy to have you. And once more, thank you for all of you being here. And thank you for this wonderful speech. And like, it was nice to see all these ongoing archaeomaterial sciences in Caucasus. And it would be nice to hear more from the young scholars and to share our research among like the young scholars, and to use all data what has been done, and also build up the new data from with new science and plus already existing research what has been done from Soviet times until now. So thank you so much once more, and have a nice evening or afternoon or morning. So where you are depends. Thank you.
Thank you, Magda. Thank you,
Thank you.
Elena.
Thank you and bye.
Thank you.
It
bye.
was a big pleasure to see you and participate. Thanks a lot to everybody.
Thank you. Thank you very much.
Thank you, everyone.
Thank you.
Thank you.